Does the mic work? Okay. So I guess we're going to start and introduce myself. So I'm Thomas Caswell. I'm based at Brookhaven National Lab, and I'm currently co-lead developer of matplotlib. And I'm here to talk to you today about matplotlib. Since this is a relatively small room, if you have questions during the talk, please just interrupt me. That's probably better than letting me just kind of ramble. So, right. So the state is, we're very much alive in an active project. Earlier this year, we signed an FSA with NumFocus, so we are now a legitimate nonprofit target. In case you know anyone who wants to make tax-deductible donations, we can deal with that. So we have a very broad contributor base. So preparing for this, I scraped Git and got all the commits since January 1st, 2013. And if you do that, you get a graph that looks something like this. This is the cumulative commits versus committer number sorted by number of commits. So we have a small number of contributors who contribute quite a bit. However, we have an extremely long tail of contributors who give us 2 or 3 commits. The unique contributors are a little off. I think it's actually like 340. There's some duplicates in the email addresses right now. But so we're very big base. And also interestingly, if you plot this, if you take this data and scrape it and bin it by week, the top graph is the number of commits per week since 2013, and the bottom is committers. Those 2 huge spikes in the commits per week are the SciPy sprints for the last 2 years. So we have we're reasonably active. In terms of other stats, we have analytics on our webpage. We get something like 470,000 sessions a month. And Google thinks this is 190,000 unique users. I'm not sure I believe that number, but that's what Google says. And if you look at the times of the sessions, you can see it's definitely peaked by hour, and you can see peaks that I think correspond to 10 a.m. London, 10 a.m. New York, and 10 a.m. California. These are and the rest of this various analytics that come from places, and this is obviously incomplete because there's so many distribution channels that we have no idea what our install base is. Oh, that didn't render very well, but we have that's not right. Oh, okay, sorry. So we have a very, very large code base. We have something like 90,000 lines of code in the library and another 16,000 in the examples folders. And in our Git history, we go back to 2003. And there's history before this that we've unfortunately lost. So in the near term, we're actually in feature freeze for version 1.5 right now. I'm going to be showing you some of the new features for 1.5 a little bit later. And then one of the main complaints we've heard about matplotlib is our style it's a clone of MATLAB. And that has become to look very dated. We are going to do a 2.0 release that the only breaking changes that will be made are style changes to the default styles. So if you have opinions on what the default style should be, make a pull request or an issue telling us what they should be. And on August 9th, Mike Dropboom and I will have a phone call and sort out what the new styles will be. And please tell anyone you know who has opinions, please tell them. We want to make sure we get as much input as possible on this, so in 6 months people don't come to us and say, but why didn't you listen to me? So, and then we're going to try to push up the tempo of our feature releases. We have been doing about once a year. We're going to try to go to twice a year on feature releases, just to get new features out faster. And the faster you do releases, the less painful they are. So All right, okay, sorry, I jumped ahead. This is the style. This is how we're going to run the style changes. Please spread it. So now the fun part, demos. So this is, I'm going to start with stuff that's in the current release. So this is in 1.4.3. One of the big things that is out is we have a functional interactive backend for the notebook. This is a full live figure. You have mouse events, keyboard events. All these things pass through to the, if you've done any of the event handling in the native client side, you can do the same thing in the web browser now. And this is the work of a good number of people. So this is just a little sign, and you see as I click on it, I get mouse, I get keyboard, scroll works. And this is just hooked up, so any event that comes in just changes the color of this plot. So you can see it's doing as I claim. And just to be, I saw Fernando walk in. Yes, so all the events are there, and this stuff just, if it works on the native apps, it will work here. We think. I mean, this is something that we have it, but it needs the tires kicked, and we definitely need feedback on this. Also just showing this off a little bit more. Matplotlib works just fine in the notebook. And again, because you have all the callback on the Python side, you can start doing very rich. You can do the same rich interactions that you can do natively. So for instance, when I zoom on this one, it shows. I zoom on the right one, it shows me the box where I'm looking on the left one. And the code for this is actually ripped straight from our examples. Like this is just copy and paste it into the notebook, and it works. And again, you can conda install this right now. Another big feature in 1.4 that did not get enough advertisement is Tony, you gave us the style module, which basically allows you to apply a partial RC params file to your current session. So I'm cheating a little bit. This list here is what's currently on master, not what's in 4.3. But you say we have all the Seaborn styles. And you can use this both, sorry, that one was in the style module, we have a context manager, so you can apply these locally, and you can also do style.use and apply it globally. You can see this was supposed to be a later example, but what I'm doing here is anything that looks like a path we can deal with, so you can actually give it a URL, and it will go out to the internet and get your style file and bring it down. So if you have, this particular example is one of my coworkers who's had an advisor in grad school who's very particular about plot style. So he has a gist that's just the style file, and every time his advisor would critique something, he would just go add a new line to the style file, and then included a use Lahaney at the top of every one of his scripts and notebooks, and then from then on, all of his figures had that change. Just to show you that, oops, come on. All right, so it's the same plot, just regenerates it with whatever style you want. And as part of the default style overhaul, for the reasonable future, anyone who puts in a reasonable style sheet will probably just merge it and ship it. So if you have a particular house style that you want, we're happy. I mean, they're small text files. We're happy to ship them. Okay, so now I'm moving on to features that are on master. In fact, I'm going to show you some things that are only on a branch right now, but okay. So this is just a brief introduction to the object hierarchy in figures. So basically anything you see on the screen is an artist as far as we're concerned. That's the object. That's what we build our scene graph out of. The outermost container is figure, and that knows how to translate from, well, it knows how to go from its space to screen space when you're rasterizing. Figures can contain one or more axes spelled with an E. Each axis spelled with an E contains, for 2D, 2 axes spelled with an I, which are responsible for the limits and the scale. And then all the artists that are the data you want to show are contained within are children of the axes with an E. So one of the things we added is that artists now know if they've changed since the last time they were drawn. So we can selectively invalidate the scene graph, which allows us to do things like watch. You can install a hook at your embedding layer. So in this case, at the notebook layer, that after every time IPython executes code, it checks of the figures PyPlot knows about, are any of them stale? And if so, redraw those. So this allows us to do things like change the line width, and it automatically redraws. So one of so we have two kind of parallel APIs in matplotlib, right? We have the PyPlot API, which is a clone of MATLAB, and has drawIf interactive in all the functions. So when you type that function, it then draws it. And then we have the object-oriented API, which is much more powerful, it's more flexible. It's the way I think you should be doing things. But if you try to teach people to do this at the REPL, you say do a bunch of stuff, and then do ax.fig.canvas.draw, which is less than friendly. So I think this allows us to bring the full power of the objects to the REPL. And just right. So anything on these objects that changes their state will be reflected. And if you do any embedding, because this is just a property on the artists, if you're embedding this in a much larger app, you can use the same thing to determine your draw cadence. Okay. Oh, so a useful feature is that we are frequently requested is to allow to easily pass string labels into bar plots. So showing that off, and if you get the fonts right, you can put emoji in. Yeah. So you can label your graphs with emoji if that's a thing you want to do. So one other a project that actually got spun out of matplotlib is so right now built in we have a color cycle. So if you want to cycle color, there's some subset of the plotting commands that when you do plot, it says, this is your third plot. I'm going to give you the third color. But we constantly get requests for I want to cycle my markers. I want to cycle my line width. I want to cycle line style, which is now that people are becoming much more aware of accessibility issues and needing to do if you make sure things print clearly in black and white, make sure you're colorblind friendly. Cycling these other things is much more important. But going down the same route of color and having a line cycle color, or a line style cycle, a marker cycle, the combinatorics of it just get awful. So this, what cycler is this is basically they're composable cycles. So they're constructed from a label and then an iterable. And when you iterate over it, it gives you back dictionaries of the key and value. So for a single one with just RGB, so this is just color, RGB, then I could do plus, and so now I've added them together. Now I have something that when I iterate over it, will give me back dictionaries with both properties, which the way matplotlib does style is you can just now star quargs this into any of our plotting functions, and now you're cycling more than one style at once. And we have both addition, which gives you lockstep zipping, and we have overriding star, you get outer product. So this is a cycle that goes, cycles through colors and then cycles line width and line style internally. So that's its own project. It's under matplotlib.org/cycler. Please look at it, kick the tires, because it seems more generally useful than just matplotlib. So one of the things that has become very clear to me, particularly in conversations this weekend, is that we do need to be able to handle labeled data in a clean way. And the API we've settled on for the first pass of this is, I don't have a good example of this yet. This is too fancy. Basically, if you pass a kwarg that's data equals something that supports getItem, any arguments that are strings will attempt to look up in that object what its data is and then replace it before passing it through to the underlying function. So, this is a very fancy example of doing this. But allows you to quickly do things like that. So I didn't think this through particularly well. So what this is doing is I create a data frame which has the keys sine, cosine, sine 2, cosine 2. I then cycle over x over the keys, the y over the keys, adding some style to them. Then I just multiply those two cyclers together. And so now at each point in here, I get out a dictionary which is x, y, and then a bunch of style. And then you can just star kwargs that into a plot function that knows x and y as named arguments. And you get this graph out of very few lines of code. This is still a little experimental, but I think this is the right path to go for this. Okay. Oh, and again, if you capture the artists, we can always do things like, I actually want all my lines to be black. And it just updated all of them very quickly without having to regenerate the plot or any. Right. Come on. So I've only scratched the surface of what we have in 1.5. This is the big ones are at the top, but we have a number of other things. We have some decorators planned that if you have a function that takes an axis as the first argument, it will ensure that you always have an axis. So if you pass one in explicitly, you'll just use it, and if you don't, it will do plt.gca to get you whatever the current axis is and create one if needed. So now instead of putting that same logic in every single plotting function everywhere, we have a decorator that takes care of it centrally. And the rest of these are bug fixes, small features, small quality of life things that unless you use them. And then for the next release cycle, the big features we're looking at is working with Steve and Sylvester to integrate, to overhaul the notebook backend, to integrate with IPython widgets more cleanly. We're working with Brian Granger and his student Ryan to add trait lists to all of the artists. So now we get validation early. And then we get the ability to hook all of this into that whole ecosystem. So now you'll just be able to say, here's an artist, build me a GUI for it in the notebook. And the kind of an architectural thing is we're looking at adding better container classes. So right now we have raw artists, like line, and we have collections, which are really a optimization at the low level, and they're always homogeneous artists. So like line collection is a collection, all lines. Containers are going to be a first-class artist, so it will have its own position in the scene graph, and it's responsible for drawing its children, and it can be a collection of homogeneous artists. So the poster child for this would be Error Bar, right now when you call error bar, you get back, I think, 5 or 6 artists that don't know anything about each other. So if you wanted to go in and change, dynamically change your X and Y positions of your points, you have to go in and touch the line, the caps, the Y errors and the X errors separately. Whereas if you grab those up in a container, you could put the brains for doing that in that container. So that's that. Does anyone have any questions? You've been letting me talk without interrupting me. Yeah? This isn't anywhere public yet. Okay. What? Would it be? Yes. I will. I said that at SciPy 2, and that one still isn't up anywhere, but I will definitely try to get this up someplace. Right. So sorry.
Question. With the kind of dynamically changing graphs, so you can change the style and automatically update, that's just for a particular, it's not global, right? It's just for or is it?
No, it's not global.
Okay, good.
So you mean like when you're just doing like line.setColor? Yeah, that's local to that artist.
Okay.
I think Brian can correct me if I'm wrong, but I think with traitlets there are ways to globally touch all of them.
So can you repeat that? I was showing someone something.
With traitlets you can say I want all my lines to be with 5 now, and then all of your line objects will suddenly be with 5. So sorry for putting you on the spot.
I think we will be able to build a way to apply styles down a hierarchy of artists. Traitlet, that's not something that traitlets natively supports, but I think we can add it as a thin layer on top of
Okay.
the problem.
Okay. So either way.
And so right now, I think where that would show up is that the way we handle config in traitlets. Today, it's set up to propagate styles. Styles for us will just be defaults for attributes. And the way it's set up today is that config is applied when classes are created. And I think we can just add a little bit to allow you to apply the config after they're instantiated.
Okay. So I want to very strongly advocate that all of you who are writing convenience code for yourself to do somewhat higher level plotting than matplotlib provides in core, you should really be writing functions that have a signature that looks something like this. It should take in an axis as the first argument, so it plays nice with our decorators to ensure axes. It should take in data and then some style, and then I think everyone more or less agrees with that, mostly. And the other thing is that I think it's very important to return the artists that you created that are relevant to the data you just asked to plot, because it allows you to hook this into interactive tools later. An example of this is a little plotting function that just goes through a data frame, looks at the columns, uses the information in the data frame to label them correctly, and plot them against the index, and then return them back to you in a dictionary labeled by the column names. This is a bunch of ugly code for building widgets that will be easier in the future. Right, so I have here I just build a data frame which has sign and code, has sign shifted forward and back, and then if I do this, I get this figure, and then if I build myself the widgets, can I make you smaller? Can you all still see? Oh, that. Okay. So now I can do things like, with a widget, make my lines wider, turn things on and off. Right, so having your plotting functions return the artist back allows the possibility of building these very interactive tools on top of the simple functions that you're already writing. And again, because we have all the full mass events, we have the full picker events. I didn't implement it here, but you could implement something where you click on a line and it doubles in width. So again, if you've got lots of lines and you want to be able to highlight one, there's the use cases for this quickly get very large. And then I'm going to skip through that. Right. How am I doing on time? Okay. So the last thing I want to say is something about where matplotlib, or where I think matplotlib should be in the community. So the first thing, we're very friendly. We're just slow. And part of that is we're mostly volunteer. So things happen nights and weekends. And also we have a lot of users. Like we can't break things. So which tends to cause you to be very conservative. But we're always looking for new contributors. If any of this seems to be 90% of what you want and you want to help us, I would love to talk to you. And one thing that's happened is that due to those many users, there's many uses of matplotlib well outside the domain expertise of the core developers, right? I'm a physicist by training. Mike's is CS. We have some other people. We have some astronomers, but there's no one on the core team that does finance. There's no one on the core team that does business analytics, and we just don't have that understanding of your use cases. And we really want to work with people from those domains to help them build the tools they need and to be a substrate for building those tools as cleanly and effectively as possible. So I guess this is basically the end, so I guess I'll take questions. But I was going to say thank you to John Hunter for giving us this amazing foundation. And then this is the list of the 340 or so people that have had commits in the last year and a half. So that's. Any questions? Anything you wish you could? Yeah.
So this is all really cool stuff you're showing. Well, I'm wondering, one problem I run into consistently is sometimes that not the style of the graph, but the style of the code required, depending, especially say like condition plots, which are very useful for.
What's a condition plot?
Like where you want to do a series of scatter plots conditioned on some other variable, like in say you have a pandas data frame and you have some kind of categorical variable. And
Okay.
you want to look at the different views of the same scatter plot conditioned by that variable. You wind up with using other libraries and syntax that's like wholly other, and you lose some of this cool other stuff by doing that. I don't know. It's kind of a vague question. I realize
Yeah.
there's like some way that could be
So okay.
together.
So yes, we're thinking about how to do that. So I think so you're thinking of something. This is a crude example, but this is just plotting like a facet like this is kind of what you do.
Well, those are, yeah, well.
I mean, right here I'm just plotting columns against each other, but in this for loop, right, it'd be just as easy to say, over the one of my things I'm cycling over is what I want to condition by, and then you put just whatever pandas computation you need to do there to get that.
Yes, you could, that would be one way to work, sort of a workaround, but the condition plots have like a little tile, like if you're conditioning on ranges of a continuous variable, they have like a little tile that moves across the top. It's the R.
I'm not sure I've ever seen a plot like that.
Oh, okay, I could show you.
Which just kind of goes back to what I was saying before about there's a lot of places where it's used heavily that we just don't know anything. And I guess my answer is we're trying to push this at the bottom to be this the clean API of access data style, which returns artists, and then that's the foundation to build these higher level, more interesting tools that you need. Right? Because again, these low-level things I'm talking about really are, for the most part, single axis. I'm putting one artist on one axis, which is very good from the low-level point of view, but from the point of view of a domain scientist or domain expert who wants to say, here's a data frame, make me the graph I want, that's something that core probably can never support because there's just too many use cases.
Well, yeah, but this is sort of a general. Well, I'll have to show you this. an example in code because it's hard to harmonize without it.
And also, I mean, this really is a common thing that everyone wants. We're also enthusiastic about picking up sub-projects in the matplotlib organization. If we get someone who has a plot, a kind of plots they want, and they want to work with us to build it, we're happy to host it under our umbrella and work with you on that.
Is there somewhere in your documentation where this is explained? How to write functions in this way is explained?
Yes, it's in the FAQ, which makes sense. Sorry, I put it there so I can say that. Yes, there's an example in the FAQ of usage of where it suggests this style. And again, and some of this will also get better with the containers because now you can start pushing towards these functions return a single artist, which is either a raw artist or a container. Which also now because one of the questions is okay, you've got this thing you've got a function that's going to return 6 artists. Now you have to figure out how to structure that in a way that makes sense across everything. And if the answer is you put that in a container, that makes this a lot easier. But that code doesn't quite exist yet. So, I mean, there's a prototype of it, but it's not. The tests don't pass. Anything else?
So, what I was getting, and we were talking earlier, so you kind of see matplotlib as the core API on which people can build either other packages or they can customize however they want, but the focus of matplotlib is and will be for the foreseeable future like a core drawer and everything else.
Yes. Just because there's so much stuff that wants to use it in very specific ways, and either we just pick up a combinatorically insane number of functions that, again, we don't have the domain expertise to support correctly. Like an example of this is the finance module. We have it more or less works, but every so often we get issues that we're doing these graphs just straight up wrong, and there's no one on the core team that can evaluate that statement. I mean, I definitely like to encourage all the stuff built on top of us to be as common as possible in terms of patterns and styles. And, there's probably some stuff that will end up in core that if there's 6 things built on top of us that are all doing the same thing, then that's something that should move down to us. But yeah, that's I guess something I didn't talk about is we're working with the Bokeh folks to try to make sure there's interoperability. There's at least some language we can speak between these two. And we're working with them to thinking about how to design these high-level, high-level things where you hand in a data frame and it creates 6 axes for you. That's not really an API we currently have. And trying to understand the best way to parameterize that and the best way to do that is definitely an open problem. Yes, that's going to come out of the traitlets. And basically, once the entire scene graph is composed of artists that have traitlets, you then ask those artists, what are your properties that we've bothered to trait? And we're saying that those are the important ones. And then basically right now we have a draw function which basically walks the scene graph and renders. We're going to end up with a parallel export tree walker that will walk and ask all the artists in the scene graph to tell me what your dictionary is. And then probably you'll be able to provide something callable to consume those dictionaries. And now it's very easy to write pluggable, I'd like to export to this format. So one idea is have HDF5 file representation of your plot. So that way you can include huge data without a problem. And but this using the same machinery, you can export to JSON, so we can send this to Bokeh if you want to see this in a dashboard. And And conversely, since we'll be able to consume data structures like that, Boku can say, oh, you want a PDF? Ship it to matplotlib, and we'll give you the high quality, publication-ready PDF of your graph. I mean, that boundary is still very, very fluid, but I'm optimistic we'll get that sorted out. Because there's definitely motivation on both sides to make that work. Anyone else? Anyone have general matplotlib gripes? Because I still have 2 minutes.
Is there a way to, I don't know how to put this, like test the equality of plots?
We do that in our test suite via image testing. So basically, you have a baseline image of what it should look like, and we've got machinery for rendering it to ping SVG and PDF, and then comparing them to make sure they're close.
Do you think now, with the new serialization machinery, it may be worth thinking about the question of testing at that level for equality, basically testing the semantic equality of the data structure rather than it's important to know about both. Obviously, you want to know that the rendering has changed because obviously the aesthetic and the visual quality of a graph matters in and of itself. In a plotting library, that matters.
Yeah, that is our API.
Knowing about the data structure can be very informative too.
Yes, and I've not thought about that at all.
It occurred to me because of this question. Because for the first time, we do have a chance to serialize these things.
So I can see the connection to NB greater and what they're trying to do. But on the other hand, from the point of view of plotting, if I draw my graph with one line with nans in it, to break it up, or 15 line 2D objects, or a single line collection, at some point I don't care, as long as it looks the same on the screen. So I'm not.
The use case I have for this is I do image comparisons, but like it's too expensive on the unit test level, and I have all this programmatic code that builds up these plots, and I want like immediate that I haven't broken anything before I have to do image comparisons.
Okay, so the comment was that for user land, users want to do this kind of testing to make sure their plots are coming out right of their plotting code, without having to do all the image comparisons. So yes, probably providing an easy framework for that might be something we should do, maybe.
Well, if there's a dictionary representation, there's already great tools.
That's true. Yeah, so. All right, I think that's my time. Okay. Also, yeah.